Digital design in the context of building is the end of the process of 19th century industrialization. There's a lot of hype that has confused the issue to a certain extent. The ability to make wacky shapes, we've always had that ability. The real thrill is digital technologies make what we already made better, faster, cheaper. Getting tools to run via digital information, first starting with paper tapes with holes in them, sort of like a piano roll, and then fairly quickly through computers. It's a very natural progression. Things like laser cutters, milling machines, routers. The basic platform for that machine, X, Y, Z axis, is identical to machines that were built and developed in the late 18th century. Those machines were not developed for people. A person can control two axes of movement, right? Like an Etch-a-Sketch. Pretty well. But the tool can go in any dimension it wants. Is this happy going in a straight line? Is this going in a curve? Is it is going in a curve in 3 dimensions? And a robot, of course, can move all over the place. It has 5 or 6 axes of movement. For designers, the exciting thing was when that machine code, the G codes and M codes and so on that actually run the machine tools, were able to be combined with the programs that allow you to see what it is you're making. So the drawing and the machining came together into CAD/CAM programs. When you have a 3D model that can be rotated, you can take sections at any point, and they can actually be used to run machines, your ability to make complex shapes is obviously greatly eased. Now you can operate the tool over a fixed piece of work instead of putting your work through a fixed piece of machinery.
The beginning of our involvement in buildings was Pei's pyramid at the Louvre. We came up with the fittings. Pei understood that as the structure becomes less and less, you go from this big steel beam to smaller and smaller tension rods, the level of detail in what's left becomes more and more important. The parts look simple, but they're becoming Swiss watches. Take the Condé Nast cafeteria where you have these organically shaped 16-foot long pieces of glass. The fittings that hold that glass up have multiple parts in them that are moving. People have been doing precision things for years. If you were making ball bearings in the 40s, a crude ball bearing that's 1/8 of an inch in diameter has a tolerance of maybe plus or minus 1/2 thousandth of an inch. That's a crude one. But, it would take you a day to set up a machine to actually get the precision. You leap forward to today, we'll make a very sophisticated computer solid model, send it to the milling machine in our own shop, and make a physical model in a couple of hours. I can run 5 models a day.
To be able to test a piece digitally and then physically with a different tool offset or a different tolerance, that's terribly liberating. So that if I'm designing a column and I need a dozen of them, I can spend a dozen columns worth of time on that one, and the rest are automatic. It doesn't make it any easier. I don't spend any less time overall, but my time is better spent, and I can make much more complex and satisfying things.
Fundamentally, you're dealing with real materials and not virtual materials. You can't have the building fall down. So really one of the beauties of digital technology is that I can get closer to the casting vendor who's making one of these parts. Casting is literally a black art. It's just like in the times of Dickens, you got this great dark room and at the end is this orange glow. Now he has very complicated thermodynamic models that say, I need to increase the volume of this thing by 1% because it's going to shrink. So his piece of software increases the volume and then sends it to his milling machine. So from our standpoint, that's a fantastic thing. We know absolutely that he is analyzing the same form that we're analyzing. On a practical basis now, you can marry his technology with your desires.
We're still sort of in the first generation of students who go through school knowing these are possibilities. But I don't think that you'll see fundamental changes in the shapes of buildings much beyond what we've already experienced, simply because the construction industry is based on thousands of years of taking trees, metal, and even new materials and turning them into straight things, something that's easy to ship, easy to stack, easy to make stuff out of, easy to fit into tools. So the idea that we're going to replace that seems to me unlikely. But there's huge opportunities for craftsmen to get involved with these technologies and take it somewhere else. It's happening now with architectural components, woodworking shops, metalworking shops, taking the language for conventional building components, railing systems, lighting, columns and column capitals, somewhere new, to create a culture where we don't have to go to catalogs to order everything. Digital design fits within a kind of continuum that has become sort of fully developed and enriched in the last 15 years. It's not new anymore. And so when a thing isn't new and the heat is taken off, the craftspeople, the people who really care about it, who are really going to do not the first thing, but the best thing, they're moving in.